And hello again. So where we left off last time when I was streaming the actual development of this language. So what I've decided to do is every Saturday, or at least I'll try to stick to the schedule every Saturday, actually add to the programming language itself. Whereas I'll be doing, say, some in-between sessions where I actually clean up the project itself, get it looking nice, and do my proper atomic commits. But the Saturday slots will be more focused on the content and the actual development of the language, and then the in between bits will be more remedial work and kind of possibly less boring to a lot of people, but perhaps interesting to people who like to see the thought process behind how different people make decisions about technical choices and the thought process there and things like that. So yeah, so then today I'm going to be continuing on where I left it last week, which was I had this kind of simple. So if I take a look at what we were working with initially, the idea was to get this program working, and we had gotten as far as being able to print expressions, do assignment statements, print variables, and do expression comparisons. So we can generate. We have also have integer literals. We have Boolean values, but not Boolean literals yet. And we have hard-coded support for a less than operation. So we don't have any other operators supported yet, but this should be enough to handle this feature. So let's get now one tricky thing about today that I haven't actually considered yet, though it was partly handled last time as well, is there'll be a bit of trickiness here uh, eventually with the else statement. We'll get into what's kind of known as the dangling else problem with these kind of LALR, and I think most parsers, or a lot of parsers anyway, traditional parsers, where you know you have to explicitly encode precedence into the parser itself. So we encountered this a little with something already. I believe this was operators. No, with maybe with assignments themselves, that we had to explicitly hard code precedence into the language. Did we have to do that already? Yes. So our operator had to have precedence encoded into it. So we'll actually be encountering something similar more than likely today. I actually can't remember how to resolve these kind of issues in the if branches, but it'll probably be something similar to how it got resolved with operators. So to start things off, what I'll do is I'll extract the next part that we're going to focus on, which will just be this bit. So we'll have an assignment. We'll put some debugging statements around it as well. And we'll get rid of the string literal because we don't have support for that yet. So what we're wanting is when this thing is working fully, and when we've if statements implemented, that it'll print 1, 2, 3 in our little box on the right hand side. So when we do that now, we'll probably get a runtime error because if isn't being recognized. Yeah, we have an unrecognized token. At what location? That's something I need to add in one of these, perhaps in one of these intermediate sessions, or maybe in one of the regular sessions, where we actually output the I'd say this is a Lexer error, yeah, because it's unrecognized token, where we actually output the proper location of where the error is occurring. But for the moment, we'll just do it a silly way to find out what's the location of the Lexer error. And it's at, it looks like position 20, which is after the if statement. So I'm guessing what's happening here is that parser doesn't recognize if statements yet. It's not a reserved keyword, so it's saying, oh, that's an assignment. It's assuming, because that's the only well, it's likely either an assignment or the start of a function call, and then it's saying, okay, there should if it's one of those, then there should be either an opening parentheses for a function call. There should be a semicolon, yeah, because it could just be an identifier on its own, and a plain expression is a statement. It could be part of an operation, or it could be an assignment. So it could actually be a number of things. The only thing it's not recognizing is that X could, that a variable could exist here. So what we're going to do next is add support for that. So we'll jump into the parser. And how do we do this? This should be straightforward enough for this part anyway. So it should be something as simple as if condition, which is an expression, and then in here we put in, so we'll have to have some kind of support for blocks in here. So this would probably be statement, so it'll effectively be the same as this. And let's say if that's the case, then we create we'll create an if statement for that, or an if statement in the AST. So we have, let's see, oops. Oh, I thought I was yanking that. No, okay. And we have statements here, and that'll be a vector of statement. We don't have to box those. So one thing I did in one of the intermediate sessions since the last day was I removed this box around expression because it wasn't directly nested in the structure anymore. So that gave us the flexibility to remove box from there. So I can just have a vector of statements here as well. And yeah, so I then just need to populate it over here. And we have cond and statements, and I'll save that. And yeah, that seems to be all right. We just have to now actually support it in the evaluator. So let's see, line 24. And in fact, will I get rid of? Yeah, I'll leave it around for now. It's probably all right. And the implementation of the interpreter, like this is why, implementing interpreters can be quite straightforward, is because you basically just reuse the built-in features of the language that you're implementing the interpreter in. So for example, once I evaluate, the condition and the expressions, I'll just be using the if statement of Rust to handle the actual evaluation of that. So first of all, what we're going to do is evaluate the condition, and that will need to expand into a Boolean. So we'll need to check that afterwards. So will I shadow the existing variable, or could I rename this to something a little more appropriate? Let cond and for this, yeah, that'll just evaluate to that. And then we exit if there is an issue with the evaluation. So yeah, I'm just going to override or shadow the existing variable for now. We're going to eagerly do type checking. So before we, yeah, in fact, we wouldn't want to wait until, yeah, I don't know how we would do this otherwise. So what we could do is do a match in here. Or will I do the match down here? I'll match it down here for the moment. Yeah, we'll just do it, Sean, and we'll tidy it up afterwards. So match condition, and if it's a bool b, then that's all gravy, and otherwise we'll return an error. What kind of errors do we use? Error invalid type. So here we're going to say condition must be a boolean. And yeah, bad error handling for now, but we'll expand on it later. And what issues do we have? Match arms have incompatible types, so I'll need to actually return that. And expected that, yeah. So what we'll need to do next is actually, yeah, again, bad variable names, but we'll sort those out later. And what we're going to do is, oh, very bad names. But if B, then we copy the logic that we had in eval_prog. So we could probably abstract that functionality, even though it doesn't map directly to, it's nice to have eval x, where x is an actual structure or node type in our grammar. But yeah, I'm just going to be a little cheeky for the short term and say eval block, even though we don't have a definition of block at the moment. So we do have multiple places where it'll use this kind of functionality. So what we'll do here is eval block, and it'll be use env and statements. And then down here, that'll be the actual implementation. And then we'll reuse it down here. Eval block, and that's env and expressions. Ooh, can I do that? Oh, I hadn't thought about the fact that, yeah, so that's actually call that expressions, but that should really be statements. And line 15, can't find statements. Oh yeah. And unused result in line 60. Can I do that? I'll probably have to do something like that. And what's going wrong here? So let's see. Got an actual result in here, yeah, because that won't always fire, so we need to be able to handle the case. The case where it does fire needs to match the case where it doesn't fire. So can I do this? To kind of explicitly tell the compiler that the two are the same. What's the signature for that again? It returns a result of void and a string, and this returns a result of, is that unit? Probably it's probably called unit in Rust. So expected that, but got a result, and expected the whole thing to be unit. I'm just going to make sure that I'm using the right terminology here. Yeah. So it's a type and a value. Yep. Cool. So I've meant to return the value. Yes. Okay, yeah. I can just do that because I'm returning okay at the end here in the case that this doesn't get evaluated. So that should be all right. Cool. And we've already gotten our if statement working. And if we said less than 1, we get 1, 3. Cool. So yeah, if statement on its own, very straightforward to implement. It'll get a little trickier when we add the possibility of having else ifs and else's. So let's see. Let's try that. So we print 1, 2, 3 again, except this is going to be 4. And we're going to expect this to print out 1, 3, 4. And again, we're going to get an issue here because else is not yet supported. And I'm actually not sure what my best approach is for kind of structuring these terminals and non-terminals. In fact, I should probably look this up at this stage. Compiler non-terminal. I'm guessing the terminal is the actual strings that we're matching, like the tokens. And the non-terminals, I'm guessing, are the kind of rules. Terminal symbols are the elementary symbols, and non-terminals are replaced by groups of terminal. And yeah, non-terminal symbols are replaced by groups of terminal symbols. So the yeah, so these guys will be the non-terminals, I believe. So yeah, so let's see about deconstructing this this if stuff. So I'll just call it if statement for the time being, and that'll just be a statement for now. Ooh, I'll figure it out later. If statement. And let's see if that I assume I can't. Let's see. Again, I have some crib sheet stuff here at the moment. in my crib sheets, I've hard coded it so that every if statement is followed by an else block. So in my kind of prep work for this stream, I basically I cheated So I just didn't handle this case, so I have to do it on the fly now. So let's see. One approach could be to do it like this, and I'm not sure if LALRPOP will just kind of figure it out, that if the else statement is present, then you use this one, and then if the else statement isn't present, it'll use that one. So let's go ahead and see what it can do. Now, is there a particular name for these? I could just, like, so there's the antecedent, the consequent, and is there a name for that? If I look up antecedent, then it might tell me antecedent, and maybe I'll just put in consequent to let you know I'm looking at. Oh, there's such a concept in music too. No, it just covers the if statement, I think. So yeah, let's just, you know, not get too bogged down in the details during the implementation, and we'll just call it yeah, if and else. And these are if statements and else statements. And so this is going to be the there's going to be an optional, how do I, oh yeah, some else statements. And it'd probably be simpler to just kind of wrap it up in some kind of conditional in LALRPOP. I'll just try it this way for now. In fact, yeah, I suppose I'll compile it like it is there. Unexpected token. Oh. It doesn't have that field, so it didn't seem to have an issue with the fact that I was just kind of mixing the prefixes of these two like that. I have two expressions that can start the same way. So what I'll do in that case is, yeah, I'll just brazenly keep going forward until the compiler gives out to me. So we have if statements there. In fact, I'll have to put else statements here too, but have it as none. And else statements. Could I be cheeky and just say that that this is an empty vector, and it's not really gonna care, like nothing's gonna be evaluated there. No, the purist in me just says no, you gotta structure your data right, even though it's a, you know, the same result in effect, the kind of semantics around it change slightly, don't they? Like as in one's understanding. So let's see how the unit variant is similar. Oh, I call it gnome. So 46 Oh, that's in a val, so that's just not being covered, and yeah. So AST eval. And let's see down here. So we have our if statements, and we have our else statements. And so in here we will so if let else statements, and again we'll probably have to rewrite this again once I introduce else ifs, but for the moment this should be all right. So if let some statements help convert to snake case. Yeah, yes, absolutely, thank you. That is, yeah, much nicer, as in to be consistent. But I have to, yeah, this is one thing I'm missing out on by stubbornly refusing to use IDEs is not having those nice refactoring tools. And also, even, like, I'm sure these exist for Vim as well, if I wasn't too lazy to actually go away and figure out how to install them. But however, anyway, so we have 1, 1, and 3, and then it should be 1, 3, 4, and then it should be 1, 2, 4. If we do that, and it'll be let's see. If we do that, then it'll be 1, 2, 3. So we're expecting a big load of gibberish. Should really have automated tests in here at some point, but just playing around here while we actually flesh out the initial implementation. 1, 3, 4, 1, 2, 4, and so is that what we're expecting? So 1, 3 is expected from the first block. Yeah, 1, 2, 3 is expected from the second. 1, 3, 4. Yeah, from the third block, and 1, 2, 4 from the fourth block. Yeah, that all lines up with what we'd expect. So that should be enough to just about get us to the first to the implementation of the first snippet I wrote on dev.2. So let's see, the last thing I will need to do is implement strings. So this is going to be just a very simple implementation, or a very plain implementation. It's not going to handle a few corner cases, I believe. In fact, there are a couple of areas where I'm still not sure how they get implemented. But so I'll show the oh no, that's an identifier, and then we have a string literal, and again checking out my crib sheet, I'm going to implement this as that, and it's going to be delimited by single quotes for now, and it's going to match any number of single quotes, and this will probably match new lines as well, based on other observations. And so we'll keep matching things until we get a terminating single comma or apostrophe, I mean. Now the big thing that this doesn't handle, I would assume at the moment, is escape characters, and so there's no support for escaping in the language at the moment. So your string or strings just won't be able to have single quotes in them for the moment until that gets figured out. So this is also a slightly hacky thing to do, but it should work because we know that strings themselves can't contain single quotes. We just and this string that gets matched will contain those delimiting single quotes. Then I'll trim all of them. Now trim matches will trim everything that it finds. So if we in future allowed embedding of single strings, so like our hello, and the string itself contained single quotes, but they were escaped. Trim matches would get rid of all of those, but that's not an issue at the moment. So let's see where we are now. So we haven't actually used that anywhere. So a string expression is just another expression. Oops. And that's going to be a string. And I'll add it to the AST. And now the evaluation will contain that. And this will now be both a literal and a value that our language supports. And let's see, it doesn't have n in it. And there we go. That's the first kind of suggested program for this project up and running. So this involves, what does it involve now? So we have, again, string literals, we have variables, assignments, we have operations, we have Boolean values, we have if statements, else statements, we have printing, so we have function calls. Well, what are they called? Unary function calls. We don't have a variable number of arguments yet, and we have string literals. So and so if we change that to that, and we get F, so nice. So that's working as expected, and we can remove that. And wow, it's almost like the beginning of an actual programming language, but it's not a real programming language. But yeah, nice one. So next thing to do is I just want to forgot to actually look up the second program that I'm going to be implementing, so I'll just do it off to the side here. And so we can put that to the side from the moment. So we'll have that as test one. And then the next one, I believe, involves a while loop. And similarly, this will probably be quite straightforward now, because most of the logic will just be shared with this original example. And so for this we need to implement, so what do we have here? We will have to implement the while keyword, and if, yeah, we already have support for that, I believe, printing variables, and we'll need support for this, which is, what will we do here actually? So we could, so we'll have this shortcut for increment, as in increment and assign. For the moment, we'll probably want to implement the actual operator first, but eventually we'll have the shorthand as well. So let's see, where do we start? Yeah, we kind of want to implement all of these, because if we don't implement this first, we'll get an infinite loop. So yeah, why don't we start with, yeah, we'll just start with the shorthand, I suppose. So we'll go into our parser, and this will be a statement. Now I'm going to be, yeah, even though I'm using identifiers here, eventually we're going to support more than, like, eventually we can assign to more complex structures, i.e. expressions and the like, so that we can assign to, for example, an index of an array, or a key of an object, or property of an object, I mean. And similarly, we can do kind of increment operations on those things as well. So I'll just call that opassign, and or will I just embed that into that? It depends on how similar the two are. I suppose what I can do for the moment is I will embed it, and then if there isn't, you know, if the two approaches don't overlap too much, then I can separate them out afterwards. So we'll go none here, and some operation here, and the operation. So for now, I'll just, will I put in plus, or will I actually be a good citizen and actually implement the operators enum now? Yeah, I suppose I will. So I'll call it op, and it'll have plus in it. And so I need to add that to the AST. And that can be, let's see, again, driving clone and debug. And it can be, we'll just allow it to be plus for the moment. And a lot of errors there. So what's going, is there something brutally going wrong? Well, I haven't added support for op assign yet, so I'll actually get rid of the op for the moment and just say that all assignments can have an optional op, option, and op there, and I'll have to use that down here too. And cannot find statement, so statement seems to be incomplete in some way. not found in scope, so I'm guessing the AST file isn't compiling properly for some reason. I have to go through all of those errors. Yeah, visibility issue, yeah, you know. So none of those symbols were getting exported because the file wasn't compiling, was it? Or was it something else? Am I still, oh, DT, maybe that. And yes, so now the evaluation needs to support that. Assign, cool. And then alrighty, so in the test I'm going to want to print this, and that probably shouldn't. Oh yes, yeah. So this will fail once we actually implement the operation, but at the moment it's just treating it like a regular assignment and saying, oh, that variable, you know, it doesn't care that the variable doesn't exist. But when we'll be implementing assignment, then we'll want to kick up a fuss if the variable isn't found in the environment. So yeah, that'll just print 1. Cool. So next, what we want to do is actually evaluate this operation before the assignment occurs. So let's see, let v equal, and so we're going to want to retrieve the value from the environment, and we've done something similar to that before. Let me just close some of these. And when we have a variable, can I reuse that? Do I want to reuse that? Yeah, I'll just copy paste it for the moment. And let's see. So we'll grab it from the environment. We'll perform our operation on it. So match OP, and so what types of operations will we allow in that area? That's interesting because we could support Boolean operators in there as well. For the moment, anyway, we'll just allow arithmetic. So we'll have plus, and that will be, so we need to make sure that v and the right-hand side are both integers. So, and again, we'll probably want to abstract that at some point as well. So that we'll probably want to do now. So have like a helper function to do that. So let's see. So we want to grab that. Could I? Nah, I'll take the variables directly, I think. And so we'll have LHS. So we have the operator itself, OP, we'll have the LHS, we'll have the RHS, and that'll return a result. And let's see, what do we want? Yeah, we'll probably copy this whole thing. So we have expressions. Push all those. That should probably work out all right for our uses. I'll also need to add support for less than, so that this area, because it's hard coded, all operations to be less than. So we can do this, LHS, RHS, and here, yeah, we'll figure out so based on the so we'll have to do different things based on the operator, as one might expect. What's the best order to do these things in? So at the moment, are all of our operations integer based? If they are, then we'll just evaluate it inside here. But if our different operators could support different types, then I'd need to basically switch between the different operation cases at the outside level, so that inside, I could check the types and make sure that they are all sound. But in here, I can just do a match up, and so if that's less than, oops, then produces that. And here we go, plus it be, and again, just using the primitives of the actual target, or not target language, source language, the implementation language, I guess. And let's see where we are now. So we'll probably have to, we'll have to use that up upstairs, where we have our assignment implemented. So the new V will be using the op here, and that will be an OK or an error. If it's an error, then we're going to have to return that. But if it's an OK, then we can just give it back there. So the value we get from the environment is actually going to be our LHS. So then next thing we want to do is we have our new V. So we basically just have to insert it back into the environment, actually. And is that all we need to do? So we get the current value in the environment. No, we also need to evaluate the right-hand side first, don't we? Yeah, and that's what that was doing. butchering the names here. Oh, here's the same name for two values that contain completely different stuff, right? Two completely different things. And insert name, the evaluated or the operated v. How's that? So we get the left-hand side from the environment. We probably want to actually evaluate the right-hand side first. I think that's typical in languages. Yep. And let's see. Or is it typical? Yeah, actually, I wonder. So if I pop open a new Python environment and I go x plus, if I said z abc, which of these is going to give me an error first? It's going to say x is not defined. So let's just follow Python's example and say that we access the environment first and cook up a fuss if things don't match up. So let's see here. Line 51 in eval. Expected an operation but found an option. So that is, yeah. So all of this is only happening if an operation is provided. Otherwise, yeah, if we go back to where assign used to be, I hope I don't press anything. No, that's too rich, too risky for my blood. What I'll do is I'll copy the file, and then I'll go backwards in time to try and retrieve what assign used to be. I mean, I really should be using Git for snapshotting all of these states, and in fact, yes, I will use Git from now on. Okay, there we go, and up to date. So what did assign look like before? And I'll save that, and I'll delete the temporary one that I had. Okay, so assign used to look like this, and now, so it could be either, so we're still doing this, but we're also doing this, and we're doing this first. So is there a neat way of intermingling the two, or should we just keep them separate and say that that's an op assign, like that's a regular assign and this is an op assign? It doesn't really matter too much, but if we want to keep this logic here, and probably work out a little better to separate this into an op assign. Okay, so I need to split things out. So op assign and in the parser, and is that all I have to do? Let's see. The compiler will tell me. So 9 errors. So where do we start? So line 46. Okay, so assign doesn't have that field, so I didn't save that yet. So that's gone. So line 60. Expected that, but got an option. So I must have left that in the AST option. Still not used to shortcuts on this keyboard. So expected an expression but got a result, so I haven't decomposed a result yet. So LHS got evaluated to a result, and so that would want to return that if there's an issue. In fact, I should just start from the bottom and go work my way up realistically. So that needs to be an op assign, eval 158. And field was similar. Oh yeah, that uses ends. 147. An expression can't be dereferenced, so I'll have to dereference it in the there, I'm guessing. If I go to the definition of OP, they're both boxes, so they'll both have to be dereferenced, I believe. And line 60, back to where we were. So match the operation. Expect an expression but found a value. Ooh. Yeah, that is an issue. So in here, yeah. So I'll grab this, go to this section, second usage. And it's actually in here that I will do the eval op after I've actually evaluated the left hand side and right hand side. And then eval op won't do that. We'll just do this matching. And that makes more sense. So 158. Oh yeah, these have to be values now. 107. Yeah, should I still be calling these like the likes of eval op, because that's not actually evaluating anything anymore in the strict sense of like taking an expression. It's actually taking like already evaluated values now. And similarly for that, well no, eval block is a bit different. Eval block actually is eval op. What could I call it? Do op. Do bop. Not sure. Do op doesn't sound great. Expand arith. Let's see. Let's get out the old thesaurus. Thesaurus. Whoops. Evaluate. phrase, maybe expand or perform. Execute or just operate. Operate using an operation. Not sure if I'm conflating terms a bit here, but it sounds smart, and that's very important to developers. So more important than actually being smart is sounding smart, isn't it? So let's go with that. So we've 107 expected expression, but got a box, so that probably has to do that. And then in here, found a reference to a value, but need the actual value. That could be tricky because operate doesn't actually need the value, does it? Like, it won't actually be consuming them. So yeah, so my earlier calls to it can be changed to references. And then on 154, the environment, yeah, that's not even getting used. So DT that. And cool, I isn't defined. Nice one. So that's what we want. And so what we want there is nice. Shorthand incrementing is now implemented. Nice one. All right then. Next, what do we want? Where do we want to go from here? So now that we have that implemented, there isn't really much more left. I think before implementing this while loop, this will prevent us doing infinite iterations. Can probably just jump right in. I don't think there's anything else to actually do here. And so we go. And this will be slightly easier than the if, because there's no other blocks to handle. In fact, I'll just grab that. And we have df that and dt ending grace, and oh, they should not be on the following line, they should be on the preceding line, even though that's going to take me beyond my 80 character limit. That's all right for the moment though. And we need to add that to the AST. So we have while 3x and dt that, and statement if, and we'll cover it here. And so we'll more or less use the same logic, except down here. Now, difference here being that we'll have to evaluate the condition on every iteration. So and that means that we'll also need to make sure that if an error does occur in the evaluation block, so basically we have to actually handle the result from the block evaluation too. So let's see, match that. Why don't we, for the moment, we just turn this into a loop, and in here we'll put our so we'll expand our condition, and then if the condition is false, we'll break. If not B, then we will return, or we'll just break. And then if if we evaluate the block and copy those guys, so it should either be that, in which case we do nothing. So we'll do actually an if let error here, because the OK branch has nothing of interest to us. But if an error occurs, then we want to send that back up the stack. And cool. So eval line 91. A move occurs. Yes, so we need to clone the AST at this point, or at least the conditional part of the AST. In fact, yeah. So I could really be borrowing, like the AST is never actually being modified, so I could be borrowing it. Borrowing all these evaluations, or I could be borrowing the different nodes of the AST during different evaluations. Yeah, and I think I'll do that. So line 88, like I'll leave it the way it is for now. I don't want to change all the parameters in the middle of an iteration, but once I've this section, once I've the while loop implemented and this snippet running, then I'll go back and I'll update all the expression, or all the AST variables to references, or AST parameters to references. So let's see, line 106. A move occurs because of statements in the last iteration. So again, same thing basically. Cool. Yeah, and that's that loop. So that was very straightforward. Again, just using some of Rust built-in looping mechanisms. So we evaluate the conditional first, make sure it actually evaluates to a Boolean. If the Boolean evaluates false, we break out of the infinite loop. Otherwise, we evaluate the statements block again, and if any errors occur in that iteration, then we break out, so that if we did something like y plus equals 1, then it'll break out in the first iteration. Yep. All right then. So nice one. So now what I'll do is I actually will start plugging this stuff into Git, because you know, just a snapshot. Like I'll be committing to a slightly tidier um, Git commit history in the main branch, but in this work in progress branch, I'll just be adding snapshots. So let's see. So Git, yeah, what's the status at the moment? So I'll just git add and git commit. Actually, what I'll do here is do I want to do a make check? Comment style not found. Okay, so I have to do the make checks up here actually, because like I was saying last time, I don't actually have Rust installed here, so running make check doesn't have the tools down here. I've just been running the dev loop, which uses the environment with all the tools using Docker. So I'll run that dev loop. Don't really wanted to look at that, but just some city code, and I have to finish that with a. In fact, if I indent it and make it think it's a comment, that should be all right. And let's see. Yeah, I'm not going to sort those in the kind of work in progress branch. I'll be sorting those in the main branch. So let's see, git commit. And that'll just be add. So yeah, git commit. Oh, I've some no commit messages again there for the main branch, so I'll do a no verify and add support for while loops. All right. So yeah, that's a fairly sizable chunk of the language implemented now. So we have basic control flow and variable support. So yeah, before hopping into the next piece of the implementation, I'm going to just optimize what we have a little slightly. So and that's just going to be by getting references to variables instead of taking the variables themselves, or yeah, taking references to structures instead of the structures themselves. Well, those aren't structures, they're enums. Should I say objects in that case? Not sure. Anyway, so I need to update as well the calls. And I can get rid of that clone then. Same with that. That's an interesting one. I'm not sure what will happen there. But again, I'm hoping the compiler will tell me. And let's see what we have so far. We have 10 errors. So line 162, what's going on here? Get function, not implemented for string. Do I have to do that? Okay, bit of programming by coincidence here, but Rust is fairly good that, you know, it tells you to do something. It's usually the right thing to do. Yeah, so here's the box issue. So I expected a reference, so can I just do that is what I'm guessing I can do. Yeah, it seems all right. String expected a, ooh, here's an interesting one. So yeah, so I'll probably have to turn that into a value. I won't be able to borrow it, so probably have to clone that. Should I? Yeah, I wonder. I assume that clone is basically the same as toString on it. In fact, yeah, I wonder actually, is it the same as toString on a string reference? And clone versus toString on Rust string reference. And I'll do this on Google as well. Sorry, Ecosia. In Rust, what's the difference between clone? Well, it's not. What's the difference? Yeah, I suppose. To owned. So that's if you do it on a raw string, is it? Yes, this is probably more in line with what I want, which is the idiomatic way of doing it, if there is one. String from. Looking at the options is giving me self-doubt. Yes, I relate to that. String from S. And that'll also be, can I do, actually I'm not sure what to, okay, just dereference. Oh yes, and dereferencing something like that, we'll just copy it. Nice. So it's line 65 expected string. So same thing here. String from. Or maybe would clone be clearer there to indicate that it's like that's making a copy of that thing. Yeah, maybe actually. And should I do that there as well? Is that even possible? Am I incurring a function call overhead as well, or will Rust inline that because it's very, very smart? It's a lot smarter than I am, so I would expect it to. I expect my compiler to be at least as smart as I am, because that is a low bar. 65. Try using a conversion method on the name as well. Did I have to do it on the v in at all actually? No, I actually didn't have to do it on the result. So found, yeah, that can be made into a reference as well. And can you do that? 48. Line 40. Insert. Found a string. Not sure why I have to do that, so I'll take a quick look at the other issue first, and then I'll come back to that. So expected a program node. Why not borrow? Is that line 32? Valprog? Oh no, in main. Yes, 32. So that makes sense. Okay, and so what's going on line 40? So insert. Yes, we don't need to hand over ownership of that name. We can just. Oh wait, no. Do we have to hand over ownership of the name? hum, 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 hum. Yeah, okay. I'll do that to satisfy the compiler, but I'm not quite sure why I'm doing that. In that kind of a situation, I should really research it and add a comment to say that I don't know why I'm doing it that way. But again, because this is the work in progress branch, I shall. I'll still. No, I'll be good. Cool, and we have our thing running still. So in that case, what we'll do is we'll add our updates. Just double check everything that changed. Yeah, it wasn't actually much. And do a no verified commit and update val functions to take references to nodes. Yeah, that's all right. All right then. So where are we now? So it's 20 past 5 now. Yeah. I suppose I can take a look at the next program anyway, or the next program snippet. Take a quick drink as well. Oops. Test 2. And so the next program that we have here is this. And actually there's a typo on the original sample, so I need a semicolon at the end here. And so we've got a couple of things going on. We now have list literals. We have list decomp. Could we call this decomposition? Anyway, different languages have different names. I think this is generally called a spread, a list spread, and this will be then a kind of a decompositional spread. This will be, I guess, a REST operator in Rust, I think. I'm not sure. I know that JavaScript has stuff similar to this, but I'm not sure does it have similar to that. But anyway, these are what I'll be implementing next. So yeah, I'll just be taking a quick drink first. All right. So yeah, so we've got invalid tokens galore. So let's start sorting that out. So we'll start with support for listed literals, and that should be fairly straightforward. It's just an expression, and now interesting thought is, oh, where did I jump to there? Yeah, what do we call items? Anyway, interesting thought is how to handle the final comma in a list, because different languages generally allow a trailing comma. It makes code generation a little easier, I feel, because you don't have to handle kind of, I suppose, what you could call the fence post problem, where you have this, you only want to add a comma to the in-between bits. Let's think. We generally, most of the time when I've seen it, you're allowed to have a trailing comma when you have new lines involved. Let's take a quick look to see if 1, 2, 3, and then trailing comma there, and that gets turned into an actual 3-element list. Even though I think if you do something like this, do you get a 4-element tuple? No, you get a 3-element tuple actually. So that's all right. So maybe to make things easier on myself. Ooh. I was going to say we can just make the last one optional, but we need the last comma optional, but still need to kind of account for it properly. Not really sure how to explain this, but basically we'd be adding, say, some kind of so we'll probably be using a star operator here, and we'll need to make sure that there's something here if we're going to allow a comma at the end, because we don't want to just allow a comma at the start on its own. So, well, first of all, actually, we want to allow commas between elements. So I'm going to, again, check my crib sheet, because I think I have a snippet that can handle this, do I? In my function calls. No, I don't actually. I don't have support for commas in my experimentation so far. So I'll need to do this on the fly. So what I can do here is public expression list. Do I even need to make most of these public? Probably not. And this would be a vector of expressions. And let's see, this can either be how do I say that it can be empty? Tricky. I'm not sure actually, because I'd ideally like to be able to use this expression list for both call and for lists, but I'm not sure how I'd support kind of an epsilon non-terminal. Let's see, LALRPOP. Will this turn up anything? Do they even call it epsilon usually? In I know they do in theory, but let's Google that. LALRPOP epsilon. An epsilon. Is there a way to specify an empty production? That's probably just the terminology that this one person on Jitter was using, but maybe it'll turn up something else. Empty epsilon. Where can I do a search in here? I don't use this app very often. Yeah, it's probably yeah, it's possibly into the past. Does this do what I want? Again, by coincidence, or again, programming by coincidence, but it looks like what I would want. So this would be that, and then if I have one or more of those, then so you can have an expression followed by an expression list, perhaps. And that would more or less do what we want. And if we said that the end of the expression list, the comma was optional. Now this is kind of a stab in the dark. I'm really not sure if this will work, but it could, and that's an alarming thought. So this is a vector of just the head, and in this case we want to destroy the original, like we want to how would we push this onto the vector? I feel like it would be slightly more optimal to push it onto the end, I assume, but I assume that pushes it onto the end, maybe in Q, or push start, or oh no, not remove, push. Appends an element to the back of a collection. Yeah, we want to put it to the start. And what's new in? Nightly only experimental API. Ah, interesting. What could we do in this state? It's an interesting one, because by the time we even get here, first I suppose I'll actually just put in empty stuff here, so that, you know, we'll have an empty result, but we'll see if what I'm doing can even possibly work. So so I'm going using JavaScript terminology in this language. I think. Oh no, I'll call this a list. I'm still going to call the maps objects, because they will be doubling as objects, but I'll be using a list for array / vector items. So or LMs. Don't love the word LMs. Anyway, regardless of how we implement the actual non-terminals, we are going to want to have the same AST structure, which will be a list of expressions, or a vector of expression. So let's see, how are we getting on here? That looks complicated. So that looks like an ambiguity error. Oh dear, oh my. So what's the first issue? Yeah, I think that's just by way of my my rules that I've set up. So what exactly is the issue here? Where's the start of this error? Okay, so let's see, we had some nice example here. So we have, if we're looking at, in fact, yeah, when in this state, what is this state? So when looking at a token bracket, we can reduce to an expression list, but we can also reduce to an expression list. A problem arises after having observed the following symbols in the input: bracket, expression, comma. At that point, if the next token is a bracket, then the parser can proceed in two different ways. First, the parser could execute the production at, so LALRPOP calls them productions. Could execute the production at line 46. So let's check what's at line 46. So that's this one, our epsilon match. And this would then yield a parse tree like that. So it'll just be an empty one. Alternatively, you could just have Alternatively, the parser could execute the production at line 47, which would consume the top two tokens from the stack and produce an expression. This might then yield a parse tree like that. Not quite sure what the issue is. Can I simplify this so that it's only kind of looking or giving me the minimum amount of information? So an expression can be that, and let's try that. Let's see if we can just simplify the error that we're getting a bit more. Okay, that's it's removed some of the verbosity, but still probably in the same place realistically. Let's see, can I actually decrypt what these states are trying to tell me? So when in this state, and looking at a token bracket, we can reduce to an expression list, but we can also shift. I just don't know what I'm looking at here. conflict detected, and looking at token that. I mean, I'm sure this is clear in its own way, but I do not know what way that is. Doesn't help that I think LALRPOP is using square brackets for its own rendering purposes as well, maybe for the sake of clarity here. In fact, can I reduce this even further and just say something like head is an expression and it has to be X. Will that still give me an error? Yes, and maybe I will. So yeah, the only part of my grammar is an expression list. So maybe that'll give me a bit more clarity about how I'm messing the whole thing up. So when in this state, so is it that this could be a sample? Yes, this makes a lot more sense. So I'm figuring this out as I go along. So this is like, if we consider if we say that these are the symbols, so these are steps in time, and these are the symbols ahead of our I guess the head of our tape. If we think of the symbols as being laid out on a tape, and this is where we are, kind of where our look ahead is, like what we, because we are LR1, so we can look ahead by 1, I'm guessing. And no, no, I messed it up. What's happening? So we start off with, so if we started off with comma X end of file, and then if X was there, and then we got comma, we would go beyond both of those two, and then we go back, and then we go on again. And is it the issue that these two are, we can reduce, but we can also shift? No, still not following it. Maybe if I do a little bit on paper. Sorry, everyone who's watching the screen, but maybe I'll be able to explain it better if I understand it first. So let's see. So if we start off with, so if we have X comma, we can then parse, I think, yes, I believe I understand. So the issue is likely this, because if we come across, and again, I'll introduce the brackets here again. So if we have this this kind of stream of characters, we'll match our left bracket, and then we'll match the X, and then we'll match the comma, however, that could be matching this. So if we said that, I know this produced, no, how do I specify it? Basically, this could match this production where we have X followed by a comma followed by a tail, and the tail is empty. Or we could also match this where the X is matched and the comma is matched and there's nothing after it. So there are two directions we can take based on the same input. So we need to either, so I need to disambiguate it somehow, either by changing the structure of the parser by enforcing a certain priority or precedence, or just disambiguating the thing entirely. Now, some thoughts are, if I remove that, then we can end with a comma, or we can end with an element. Actually, maybe, could it be as simple as that? Oh, yes. So, the thing that I was worried about is that we might not be able to match empty strings, but we can match empty strings there. Then we can match something ending with, we can match something ending without a comma, and we can also match something ending in a comma, because this can then be empty as well. So didn't really need to add that extra kind of optional comma. So let's see, can I undo all my comments? And yeah, it looks like this might be working now. So let's see. So the AST supports lists, but I'm not actually creating one yet. Also, I need to actually change these back. I assume that shouldn't be an issue. In fact, my evaluation, I'll just say that lists aren't handled at the moment. Yeah, unhandled expression list literal. So first of all, I'll add the proper build up here. So what's my best way of handling a list in this way? Would it be to somehow, can I build it in reverse actually? If I did this, then it means that it could start with an optional comma, which is not what I want. Ending with an optional comma is fine, but starting with one is just bizarre. So let's think, what could I do to make this somehow efficient? Now, maybe I could, yeah, do the usual of just not worry about efficiency for now and put it off till later. Can I do, yeah, I suppose I will. So can I do something like head plus tail? Standard ops add might be missing for expression. Maybe I'll just, yeah, Rust vec enq. Vecdeck. Yeah, maybe I'll just do a very stupid implementation. Where I just drain it every time, or is there a concat operation, or why don't I assume I could probably do that actually. Nope, can't add them. Can I insert at a position? Ooh. Zero head. And I'm guessing. So if I insert 1, 4, yeah, that goes in at that position. And consider removing the semicolon. Yes, that would be wise. Cannot borrow as mutable. Consider changing that to mutable. So what would I'd have to do? An immutable operation. So is append self has to be mutable there. Drain self has to be mutable. Is there a concat? Oh, I could clone it, I guess. Ooh, painful. Yeah. Oh dear, oh dear. Anyway, so Evans is currently just one character. That doesn't seem right. Or just one string, I mean. So let's see, it should be 2 strings. So let's see, can we get that sorted out? Not sure if this actually works. Yeah, that makes sense. So tail and head. Because I inserted into the I'm not the sharpest. List insert and yeah, ooh, no, still not working. So print. So there is the B and the C. Oh, goodness gracious. Yeah, there we go, finally. So unhandled expression, and if I go to the evaluation, unhandled expression. So let's see. And this will probably just be, in fact, this would be a literal as well. How about just X's? And that'll be a vector of value. AST, we'll call that X is 2, and in our parser, we'll call that X's. Though not in love with that name, but it's okay. Go back to eval. What's going on here? 127. Expected enum found an expression. So I'll have to evaluate the items in here. So yeah, is there something else that's doing something similar at the moment? So for arg in args, yeah. Maybe I'll abstract that as well. So evaluate expression list. And eval block for consistency will be renamed to eval statements. And eval expressions will be basically the same thing, except that we return a vector of values after. And let's see. So it was used in the call. So let's replace that. Let vals equal eval expressions, and this will be env and expressions. In fact, I can probably hand it over, but Rust probably wouldn't like that anyway. So let's see, where are we now? We have 3 errors, and need to actually use it in this new spot. Val expressions and x's, and can I just do this? Well, I can't have a colon there, or a semicolon there anyway. That might be alright. We'll check it out. Line 118 first. No, I changed the number of lines. So 186 vals expected a result. Yeah. 164. Not sure what's going on there. Line 127. Expected a vector. Oh yeah, I need to actually handle that. Let x's vals and 164, probably something similar. Yeah, I'd say I need to match the potential error. Match that. Not really saving much code there, am I? But how's ever, I'm saving a little and the abstraction makes sense, I think. Oops. And 129, match the valid expression, need a semicolon there. Line 134, expected not that, and expected that there. 129, expected an expression but found a vector, so probably have the wrong, oh no, what is going on here? 129. So expected an expression there. Oh yeah, not actually calling the right function. Whoops. Probably an argument in favor of giving my functions better names, but here we are. Okay, let's see where we are now. So test, and we'll print x's, and we get BC. Nice one. So cool. So that's an implementation of list literals. So that seems like a good enough place to park it today. I'll just commit that. Git add p. Make sure, I'll just do a double check of everything. Yeah, all seems fairly fine. I won't commit that. And I'll add test2 and do a no verify commit. So add support for list literals. And let me just check my git log, see add support. Yeah, I'm using the same terminology. So add support for list literals and save. So nice one. Yeah, that's a pretty handy amount of stuff to have implemented today. So what did we get through again? So there was if statements, there was else statements, didn't actually have to work around the dangling else problem really there. That'll probably crop up. Oh wait, no, we won't have the else problem. It's likely that we won't have the else problem because we always require parentheses around blocks. So that could just be an issue when in the likes of Go or C style programming, where you have, if A less than B, then f of x, else if, and then you have B is less than C, how will it go again? Because they don't always have blocks. And we could have else, and we have g of y, but that could belong to either of those. So, but by requiring braces, it means we just sidestep that whole issue. So actually, we might not need to bother with resolving the dangling else problem. Nice. But there was a potential conflict with generating the lists due to the fact that there could be an optional comma at the end, and there was just a bit of my own silliness there that resulted in some ambiguity that we eventually resolved. And yeah, this is still horrendously inefficient, but again, it works, and that might even be all that's needed for. Again, this is a research language, so I might not need to bother optimizing it. Even though there were some nice optimizations done today as well. And in addition to those, so we also got if statements done, and we also got while loops done. We got shorthand assignment operations done, and we got list literals. So so that was a pretty tidy amount of stuff to get done today. So yeah, thanks everyone for watching, and yeah, I'll be